The whole point of doing the STEM Sense project was to connect students with science and technology in the form of instrumentation.
In the CO2 lab, we were able to use a modern CO2 sensor and an Arduino microcontroller in order to make CO2 measurements through a computer interface. This updates the standard biology experiment by replacing subjective measurements of bubble diameters of CO2 with empirical measurements of numerical data of CO2 concentrations on the computer screen.
When the students arrive in the classroom, they're given a basic introduction about respiration. Once we introduce the students to the carbon dioxide sensor, part of the class begins the pea experiment and the other part of the class begins the yeast experiment. So at each table we have a setup where students are sensing CO2 from yeast and CO2 from pea respiration.
This is our final setup, what it looks like. From there, the Ethernet cable is running into our chamber. Inside of our chamber, we have the K30 CO2 sensor and another setup connecting our sensor back to our Arduino with the transmit, receive, and the power and 5 volt. We keep this inside of our chamber here. From this, we have our tubing connecting to our yeast. We have this setup going on in here, again inside of our container. Within here we have the direct setup on top of the CO2 sensor, the same one we were using for the yeast. However, this time we have the direct connection going directly into our container with our peas.
With the new lab, the students can directly see, they can actually look at the computer screen and see the carbon dioxide in parts per million. And it not only connects the actual experiment to carbon dioxide into the net reaction of cellular respiration, but it also connects them to the actual CO2 levels in the room and the graphs that they may have seen of the amount of CO2 levels in our atmosphere.
The STEM Sense project is really about showing students that they have the capability not only to make measurements that inform the scientific process, but they can design the systems and alter the systems that make the measurements.
The STEM Sense labs lend themselves to inquiry and research-based learning, so students use the Arduino microcontroller and the K30 sensor to measure respiration output of peas and yeast, but by providing other study organisms or access to supplies that could change respiration rates, students can do their own research on respiration. This is the type of hands-on learning in the STEM fields of study that we're trying to promote in this STEM Sense project.